does. All right, so I'm going to do basically a preview of Project 4. I have not finished all the loose ends with Project 4, but I have the vast majority of it at least explained and ready to go. So I'm going to present on essentially a preview. Keep in mind this PDF is going to change, but the main concept is definitely not going to change. So you can definitely start looking at this. You can play around with some of the code if you want to, because the interface, I doubt the interface is going to change any. If it does, it'll be pretty minor. And you can also be thinking about it. Okay, so Project 4. Y'all ready for Project 4? Ready, Jonah?
Yeah.
Okay, good.
Ready as I'll ever be.
All right. For this project, we are trying to find the minimum overlap of sets that still cover all points. Let me give you maybe a little concrete example. I was trying to think of how this would work in real life for you. Let's say that we have numerous group projects for a class. You took OOP with me, we had group projects. Well, let's say for a class, and they need, or at least some of them need to be presented. Not all of them, actually. Your professor must grade every student at least once, but he does not mind grading multiple projects. Also, I don't have to grade every project. I just have to be able to grade every student, because I'm grading the student. Due to the nature of the project, students are members of multiple projects, but only want to present once. So you have multiple projects, students are members of multiple projects. Students only want to present once, and I have to grade you at least once. Everyone okay with that so far? All right. How can we minimize the number of times a student has to present?
So wait, so there's a bunch of groups that are working on projects and students are members of multiple?
Mm-hmm.
Oh.
And so
And so what?
and so every time a group presents, every person in the group's up there?
Every group, yeah. There is, naturally everyone in the group has to present. There is no partial group presentations. So the whole group has to present or the group does not present.
So
But the person only gets graded once.
I will grade the person every time. You want to minimize the number of times people are graded. Might be a better way of putting it.
Okay.
So that's a better way to put it. Minimize the number of times your professor grades someone. There we go. That's a good way to put it. I'll change that because that's an even better explanation. Now, I really was thinking, a student only wants to present one time. So you want them to present, you want to try and minimize the number of times each student presents. But I think the number of students I grade is a better way of putting it. Welcome. Everyone kind of understand this problem? I mean, understand what I'm asking?
Yeah, I understand what you're asking.
I guess the thing I'm kind of confused about is if a student's in a set number of groups, he's going to have to present that number of times.
So I do not have to grade every project. I just need to grade every student at least once. But a student only wants to go up once. So there's this min-max thing. Like I have to grade every student once. That has to happen. But a student doesn't want to present more than once. So we're trying to minimize the number of times every student has to present. I think your way of putting it is, how can we, if there's 10 students, I have to grade at least 10 times. How can we minimize the number of grades I write? Because I'm going to grade every student when they present. I only want to put in 10 grades or have 10 grades. How can I minimize the number of grades? Because I might have to put in 13 and that's the minimum number, right?
Just one big project.
But that didn't happen.
That everybody has to work on.
It's too late. We're at the end of the semester. We got to deal with what we have.
I've actually had something like that
Really?
for a final week student, the whole class got together over the study guide.
Oh, that's good.
That's not, the study guide is not too bad.
Okay.
We were at USC, there's over 50 of us in the class. Imagine that document.
So the files you have, first off, each file in the data directory contains a group of sets, which represents the groups that may present. For example, let's scroll down to what that looks like. The group set file. So here we have 6 groups. The first one, and I'm just giving each student an ID number. Okay, I'm sorry, I reduced it all to a number. But I believe that's easier than if we played with names. That's all. I was just trying to simplify this problem.
That's all we are anyway. It's our ID number.
Yeah,
Because you can't do anything without your ID number here.
So group, 1 or 0 has 0, 2, 5. The second one 0, 2, 3. And then the third group is just 1. Man, that guy's nice. Fourth group is 2, 3, 6. Group 5 is 1, 4, 3. And the last group is 5, 6. So there's 0 through 6. So that's 7 people and 6 groups. You go ahead.
So what you're saying is that groups, the third one down and the last one wouldn't have to present because all of their members have presented before.
Okay, so if I was asking that all 6 members needed to present, then yeah, what would be the minimum here? I didn't even think of that.
The third one wouldn't have to and the last one wouldn't have
Yeah.
to. 5 and 6 have already gone and the last one and 1's already, oh wait, no, 1 hasn't gone.
Well, yeah, I mean, 1 could also go by himself. Remember, we're trying to minimize the number of grades here.
But if we take out 4, then
Oh, so
1 and
this one
4.
has to happen, right? He's the only one with 6 in it.
6 is in the
not-
fourth one.
Oh, he's in the fourth one as well. Yeah.
So-
Getting complicated, isn't it?
So if you,
So you could take out the second one. Or no, you could take out the third one.
you got the third one, you got the last one, the 6 and 5, and gone already.
The 6 wouldn't have gone if you take out the third or the fourth one.
If you take out the third one and the last one.
4 is only in 1 of
6
those.
will
Oh,
go
the
forward.
third one. I'm sorry.
Yeah.
All right. All right, so we have different set files. This is a very simple one. Obviously, I could make it to where we have hundreds or thousands of students, and then I don't know how many groups I feel like having as well. Because your professor will do that, just FYI. It's coming up, it's happening, it's gonna happen. I'm gonna do it. I'm gonna do it.
Just give this one. Take out 2,
Let's
3,
do the
last
2
one.
groups. Just 1, 2, 3, 4,
All right.
5, 6.
Under source main, I have a general purpose test program for running test cases on your code. It also produces timing information for you, how long it takes your code to complete. I have a minimum overlap HPP's header file for your class, compute the minimum overlap, and the CPP, of course, is your set file, or is your source file. So here's the output of each set. Group file contains multiple sets. Each set is contained in one line and is spaced a limited list of numbers. I'm using set and group interchangeably here. You may think of them either way. Each number represents a student's ID, for example, here, starting at 0. And I'm
So
all.
like I'm sorry.
And I'm always going to start at 0 and move up in the numbers. Yes.
Is there going to be like a maximum number of people in a group?
The maximum number of people in a group is, of course, the entire class size. So if you encounter that, then obviously that's your answer.
Yeah, because if you could just delete, or you just don't have to do everything.
Right. You just have one massive group project.
So if you find that one, you're done.
You're done.
Once.
All right. The header file for this is, it kind of zoomed out over there. I'm going to fix that. Is actually fairly simple. You have to implement 2 functions. It's only 2 functions, guys.
No.
Don't say that.
Don't say that. I know what that means.
That's always a trap. That's always a trap.
Hey, don't trap.
Okay.
Can we have the Boeing guy do mock interviews instead?
Yeah. He said, can we have the Boeing guy come do mock interviews instead?
I remember that.
All right. So the first one, I'm going to pass you the set file, and you can do any type of pre-processing you want to do on those sets. I'm going to first give you the set file, and I'm going to call that once. That's why it's your constructor. Now the reason why it's going to get tricky is the next one's find minimum overlap. I'm going to give you a cover. So I'm giving you a set of students I want. Maybe a couple students drop the course, so we don't need to take those into account. So I'm just going to give you a vector of all the students that do need to be graded. And then you return the number of number of overlaps possible given the cover, minimum number of overlaps. So, example, if the number of students was 10 and we somehow configured it so I'd have to only grade 13, do 13 grades, the overlap would be 3. I'll make that a little simpler to understand. Because I can see that that's confusing. But I'm going to give you the number of students that need to be graded, because maybe some dropped. And then you have a constant bool print. This is really just a helper. This is for debugging. If you want full debug, you gotta just pass print, and then you can just print off a bunch of debug information. This is just to help you out. And this is just const afterwards. So all this const means that you can't change anything. You can't change print, you can't change cover. It's all that's saying.
So that last function right there, so given the sample
This-
data that
yeah.
you input, that one would output like 4.
Sure. Yeah. I'm going to call this second one multiple times. It's not being called just once. I'm going to give you the set file I'll call once during a program run, and then I'm going to call this find minimum overlap multiple times. It may be 3, and maybe 10, and maybe 20. So,
It has to work every time you call it.
right, it has to work every time you call it. So it's to your advantage to do a lot of pre-processing up here on the constructor. I'm really grading you on the second function. But if your first function takes days to complete, you know, that doesn't work. Don't be doing that. But if your top function takes a couple of minutes to complete, and then all the rest of it runs in like 0.1 second, you'll probably get an A.
So you're saying the first part is the hardest.
Well, maybe.
Dang it!
It depends.
Well, because the first part's finding the minimum overlap.
No, the first part you just read the set file, and then you can do whatever you want with that set file internally. I'm not limiting you to what you can do with that. You can do whatever you want to that. Try and compute every possible set combination. Sure, go ahead. I can't. Well, you will run out of memory, but sure, you can do
I was
that.
about to say, you told us to don't take days.
Yeah. So, all right. The algorithm setup. If you study this problem long enough, you're pretty much going to have to come down to a recursive backtracking algorithm. So I'm going to go ahead and set up that algorithm for you. Isn't that nice of me? Yes, thank you. Thank you. Thank you.
I appreciate it.
So what happens is, the top one, you do whatever pre-processing you want. The second one is where it gets complicated. The second one, you're going to end up calling another function, recursive. Notice that it has a different function heading. Also notice that in this function heading, I have not defined what so far and input are. You are going to define what those are. It's up to you. Or you can define this function to be something different. I'm not strictly limiting you to this. It has to be recursive backtracking, but it doesn't have to be exactly this heading. You just have to adhere to this interface up there. So, what does this function do? Well, so far is going to represent the sets you have chosen so far. Like maybe up here, you've chosen 0, 2, and 3. And let's see, then you would still probably need 5, 4, and 6 in order to complete a cover. Does that make sense? So far just tells you which sets you've chosen so far. An input represents the student IDs that still need to be chosen. So maybe I've started you with 0 through 6. You've already taken a couple of them, and now only 3 and 4 need to be chosen. So input at that point would only be 3 and 4. All right? Maybe an example on the board is going to help out here? Sure? All right. Let's go ahead and write these sets up here. Let's see if, all right, so I have a little dot thingy up there. Okay, great. Let me go ahead and write this. We have, what do we have? 0, 2, 5, 0, 2, 3, 1, 2, 3, 6, 1, 4, 3, and 5, and 6. So these are your different sets. Set 0, set 1, set 2, set 3, set 4, set 5. You do not have to represent your set this way. In fact, I recommend you don't, but I'm going to do it this way just for clarity. All right? So far represents the sets you've chosen. Let me go ahead and show you on the board. Those are our sets over there. Let me see if I can fix this just a little. There we go. So first time so far is called, we'll say it equals nothing. All right? We'll start at the beginning just to make this easy. Input represents the student IDs that need to be chosen. Let's say, for sake of argument, We'll go 0, 1, 2. Is that going to make it too easy? And 5. 5 or 6? Let's do 6.
What's happening outside?
Someone's definitely backing it
For a
up.
very long time.
In the pond or something?
Wow, this camera is not doing well. All right, there we go. So far, it starts off empty. Input is whatever I've told you. Remember, I may not be using the entire class size. I may be only using a portion of it. Print is for your convenience. In other words, if you want to print something out, you just do if print is equals true, C out, blah, blah, blah. That's just for debugging. That way, if you want to turn printing off, you get some real timings. You turn printing off, and then you'll actually get some timings that are useful. Because printing consumes a lot of time. Minimum, notice minimum right here. I don't know why count is in there. We'll remove that in a moment. Minimum represents the minimum number of overlaps found so far in a cover. Right now, unsigned int max, just saying we haven't found anything yet. Result is what's left over from removing and evaluating set. We'll get to that in a moment. Okay, so for each set S in the set file, so we have sets, the way I'm representing it up here, we have sets 0 through 5. 0 through 5. So we're going to have a for loop that goes from 0 to 5. And we're going to start at 0. And what we're going to do is that we're going to have result equals the input minus that set. So I'll call it set equals 0 through 5, just to make this a little cleaner, hopefully, minus S, because set currently is pointing to 0. So input is 0, 1, 2, 6 minus 0, 2, 5 is just going to equal, what do we have? 0 is taken out, we still have 1, 2 is taken out, so we'll have 6. You see what I did there? I graded some extra students, that's okay. We don't actually care about that right now. Result 1, and 6. And then the next step of this algorithm, if result has no members left, I'll just do size equals 0. That means we found something, right? So we need to, at that point, update min, or update min if needed. So if the new min from that evaluation is 0, then we're done. Then we need to update, compare it against min, see if that is a lower number. If so, update min. Otherwise, if the result is not 0, that means we have something else in there. We now need to recurse. Let me show you how we do that. First, we add S to the end of so far. So we do so far plus equals S. So then so far, that implies so far is going to be, what is it? S is 0, 2, 3. So we have 0, 2, 5, sorry. And then we do the recursive call, right? Right. Find min, which is the recursive call back up here of our so far with the result, right? Good. And then print. So we're just going to add to what we found so far and then pass in result what we've computed and print it as well. So this is the recursive part. Afterwards, yeah, we'll have cmin equal that. And I'll just say update cmin if needed. And then now we have to subtract, right? Yeah. Now we have to, well, now you got to be careful here. remove S from so far. Now this part might get a little tricky for you because if you have 0 already, you're passed in 0 up here, and you're down here and you've added 1, you don't want to remove the 0 from so far because that's what was added up here. So you got to think about how you can go about doing that as well. In other words, you need to make sure that so far takes into account duplicates. Does this algorithm make a little more sense? Okay. As usual, you may change the public, you may not change, whew, that was close, public interface, but you may add any private data you want, any methods you want. Since we're using backtracking, you're going to probably have to add at least one function call for the recursive function call. Keep in mind the above pseudocode, because I never defined what so far's type is, nor have I defined what input's type is, so you can figure out what's going on there. Notice that data stored in the private section should not depend on a particular call to find minimum overlap, but only on the set group file. The reason for that is I'm going to call your find minimum overlap multiple times. So you don't want that to be permanently changing your private data, because I'm going to be calling that function again. That's all I'm trying to say here. Make sure that you don't do something that would mess up a second function call, because I will be calling it multiple times. You can declare data locally within that, or pass this parameter, so you can add more parameters to your recursive function call if you want to. Pass by reference is faster than by value, especially for bigger data items, so keep that in mind. Keep in mind that const does give some performance improvement, but not much. So if you really want to eke something out, you can probably add const to the end and see if that'll help any. Naturally, you may create as many helper classes as you like. The public interface of those classes is completely up to you, subject to a good design. In particular, you'll need to have a representation, possibly a class or a struct to represent a set or a group. You may use anything from the STL or roll your own. So I'm really letting you go. You can use whatever you want. I doubt they have this function in it. Maybe they do, but I doubt it. All right.
There's a chance.
Just chance.
Are you telling me there's a chance? You're welcome.
Whew, that was good. All right, I'll get some example runs and some example timings out in a moment, or later on when you get back from the weekend. But at least you have something to think about. I push this up. Keep in mind that I will be grading you on memory management. Make sure you submit that. This is due, should be December 2nd. December 2nd is when it's due. So, wait, how much time is that? Is that 2 weeks, 3 weeks?
I think it's 3.
Okay. 3 weeks. All right. All right. I'll try and give you some example test cases as well, so you can make sure that your code's actually working correctly.
Wait.
December 2nd.
2nd?
Yeah, when is that? Is that a Friday?
Saturday.
Oh, well, congratulations.
Okay.
You get until Saturday. Next I know you'll be doing that Saturday.
Yep.
Wow. Don't, hopefully you
Oh,
know,
yeah.
do not wait. It's not going to happen. Any other questions? Let's at least get you started as you're finishing up Project 3 and you're thinking about it over the weekend and possibly trying to do some other labs that you may have missed. No other questions? Comments?
Got a couple screens.
Go ahead.
Couple grunts.
All right. Well, good luck, guys. I will see y'all on Monday.